All right, here's 4 excellent questions. I like these ones. So the first one says they give you a log. They don't tell you what base it is, but they say log base 2 is this. Base A is 6 that, A5 is that. And they say, what's the log base A of 48? So the key to this is to break this 48 down into 2s, 6s, and or 5s. Now, 5 won't go into 48, so it won't be using that one. But I think 6 and 2 will. So let me rewrite that as log base A of, instead of 48, let's say go 6 times 8. So there's a 6, that's good. But the A, I don't have 2's. But this 8 I can write as some 2's. So 6 times 2 times 2 times 2. I think that's 8. There. Okay, so now I've written that 48 as a product of numbers for which I know what their logarithm is. So now I need to separate these out, and I can use the product law to do that. So if I'm taking the log of a product, 6 times 2 times 2 times 2, I can separate it all out. So it's log base A of 6 plus log base A of 2, that's out. So I've got those two, plus another log base A of 2, plus another log base A of 2. Okay, so now this log base of 48 is equal to this thing. So, but this log base A of 6 up here is 1.792, so I can just write that for it. Plus log base A of 2 is that, 0.693, and then of course I have another 0.693 and one last one. So now all that's left to do is to take and add those numbers up to see whatever that is. 1.8, 3.5, 3 point, I don't know, maybe 4 point something. You can add them. Okay, the next question, love this one. Radioactive has a half-life 2,000 years. How many years would be required for a given amount of this to decay to 40% of that amount? Okay, so I need to use this formula. P of t equals P0 e to the kt. Now, they say half-life, so that means it goes from, say, 10 to 5 in 2,000 years. Okay, so from 10 grams, say, to 5 grams in 2,000 years. So this is P0 is how much you start with, so let's pick 10. It doesn't really matter because it says half-life, so whatever half of whatever number you put here is. So let's maybe try 12. So say I start at 12, okay, let me put my 2,000 years up there. In 2,000 years, it'll decay to 6, half of 12, or 6. Now I need to solve this equation to find out what the constant of decay is. Okay, so to do that, I need to isolate this term that has the exponent in it. So I'll divide both sides by 12. So that'll give me 0.5 is equal to e to the k times 2,000. Now change it from exponential to log form. So it'd be log base e of 0.5 is equal to k times 2,000. Then to solve for k, divide both sides by 2,000. Okay, let me do that on my decimals. So log base e, remember, is ln. So I got to go down to ln. Where's my ln? Right there. Of 0.5, close my bracket, divided by 2,000. So my k value is negative, and that makes sense because it's decreasing. 0.00034 34657. Okay, so that's my k value. Now I can use that information to help me with the question. It says how many years, so I'm looking for t, would it be required for that given amount of isotope to decay to 40% of that amount? So again, I'm going to use this formula, e to the kt. This time I'm looking for t, but they say I'm decaying to 40% of something. So I must start, this is start, at 100%, and I'm decaying to 40% of that. is equal to e to the k, I just figured k out, negative 0.000346657 times t. And now I'll solve it just like I did the other one. Divide both sides by 100. So I'll get 0.4 is equal to e to the negative 0.0034557t. Change it to log form. Log base e of 0.4 is equal to that thing, 34657t, and then divide both sides by that. Negative 0.000346657. Divide this side by negative 0.0034657. And so once I do this, that'll tell me what length of time I did. Okay, here's another one. How many 2-card hands are possible with a 52-card deck? So there's 52 total cards, and you're choosing 2. Doesn't matter the order? Perfect. Suppose 5 cards are drawn from 52 cards. What's the probability? So probability, I need something on the top, something on the bottom. And I'm drawing 5 cards from 52. So the bottom thing, the total number of ways that you could choose 5 cards from 52 would be 52 choose 5. And then on the top, they want to get 4 kings with any other card. Okay, so let's figure out kings and then other card. Okay, so let's just look at kings. How many total kings are there? There's 4, and I want to choose all 4 of them. Okay, so that'll get me my kings, multiplied by, fundamental counting principle, any other card. So how many other cards are there not kings? It'd be 52 take away 4, so there'd be 48 cards left, and all I want to do is choose one of them. So that'll tell me how many ways I can get 4 kings with any other card. To do the probability, I'd take that number then and divide it by 52 choose 5. And you can just do that on decimals or a graphing calculator. And at the end, I always would hit that fraction button. So just it would change it to a fraction for me. All right, last one. Cylinder John Gutenberg's press, 38.5, so diameter 38.5. I never use diameter, we're always using radius, so that'd be, I think, 19.25 centimeters. The linear speed, so that's velocity, is 128 meters per minute. And they want to know the angular speed, that's that W thing. And they want it in revolutions per hour. Oh, great. A lot of conversion here, I think. All right, so my formula is V equals RW. I'm searching for W, so I'll divide both sides by R. So I'll get velocity divided by the radius is the angular velocity. I'm just going to rewrite that just so it's like this. Okay, my velocity, 128 meters per minute. And my radius is 19.25 centimeters. Now, right away, I'm seeing I got troubles because I want revolutions and I want hours. So when I do this, I think that I'm going to get radians per minute, and I'm going to have to convert that. One issue I see right away, though, is this: I have centimeters and meters here. I'm gonna do that conversion first. So I know there's 100 centimeters in 1 meter. Okay, so centimeters cancel, meters cancel, so I'm good with that. Now I have minutes down here, so let's change that because I need hours. So I know there's 60 minutes in 1 hour. So that canceled my minutes out. So now, it's not really shown, but anytime you're looking for angular velocity, your units are radians per given time. And in this case, I've got them converted to hours. So if I do this calculation, I could keep going with the dimensional analysis, but I might as well come up with this one here. So 128 times 100 times 60. Okay, divided by 19.25. Okay, that comes to 39,896 and change radians per hour. So 39,896 radians per hour. Now, if you get to this point, I'm pretty happy there, but they do want revolutions, so I need to multiply by a conversion unit to take me from radians to revolutions. So I know 2 pi radians are the same as 1 revolution. If they wanted to change it to degrees, I would have just put 360 on the top there. But they want revolutions, so I'm just going to take the answer that I got there and divide it by 2 pi. Whoops. 2 pi. So that comes out to 6,349 revolutions per hour. That's how fast that printing press would be going. All right, hopefully that helps you with those 4 questions.